kids, I'm Miss Rivers.
And I'm Miss Lane.
We're about to travel to several different landmarks around the world to show you how math is everywhere in real life.
We will be stopping at Niagara Falls, Mount Everest, the Taj Mahal, the Great Pyramids of Giza, and the Great Reef. Bon voyage!
We are here on the Nape of the Mist, quickly approaching the Niagara Falls in Ontario, Canada. This unique landmark is one of the greatest natural wonders of the world and is only about 2 hours from Rochester. The falls are so strong that even this far away there is mist everywhere. The Canadian Falls are known as the Horseshoe Falls and are 167 feet tall. Take a closer look at their shape. Looks more like a parabola than a horseshoe. The length of the brink, which is the edge of the land that is cut off right before the falls, is 2,600 feet. Water never stops flowing over the falls, which is why there is so much water volume every second. The volume of the Niagara Falls is 600,000 gallons per second. Let's do a little math here. You have been watching this video for approximately 1 minute. If there are 600,000 gallons of water going over the falls in 1 second, how many gallons have gone over the falls in the time you would watch this video? Now would be a good time to set up a proportion. If we did this, we would figure out that there are 36 million gallons of water going over the falls in 1 minute. Imagine how many gallons would have gone over in 1 hour. The number of gallons would become so large that it would be helpful to use scientific notation to represent the immense amount of water flowing over these falls.
We are standing on Mount Everest, another natural wonder of the world, located on the Nepal and China border. This is the largest mountain in the world at 29,030 feet high. This is 21 Empire State Buildings stacked on top of one another. The mountain is rising at approximately 1/3 of an inch per year and shifting 3 inches per year. The temperature in the summit, or peak, ranges from 32 degrees Fahrenheit to -76 degrees Fahrenheit. We can use the rise and run of the mountain to calculate the slope of various peaks. We can also calculate the survival rate of climbers and the average length of time it takes to ascend the mountain. Next, we're going to travel to India to check out another wonder of the world.
Now we are looking at the breathtaking, extravagant Taj Mahal in India. This is one of the most impressive and beautiful examples of the use of mathematical symmetry in an architecture. Symmetry is when one shape becomes exactly like another shape when you reflect, translate, or rotate it. This building and the structures surrounding this building are filled with different types of symmetry. The 4 sides of the Taj Mahal are identical, each one featuring a huge vaulted archway. When looking at the building, it is obvious that it has vertical symmetry. This means if we draw a vertical line right down the middle of the Taj Mahal, each side of the line would match up perfectly. Not only does the outside of the building have symmetry, the decorations and the tiles throughout it are also uniquely symmetrical. In front of the mirror image gardens of the Taj Mahal, walkway stones are laid in a pattern that combines squares and hexagons to create regular octagons. Even the reflecting pools of water add to the wonderful feeling of mirror symmetry. It is truly a vision of geometric elegance and surely a sight everyone should see.
Whew, took us a long time to get here. We're at the Great Pyramid of Giza in Egypt. This structure is one of 7 wonders of the ancient world. There are fascinating and mysterious mathematical measurements and facts related to this pyramid. The base of the pyramid covers an area of over 1,300 acres and stands at a height that was the tallest man-made structure in the world for almost 4,000 years. A cubit was one of the earliest units of measurement. The pyramid's perimeter is approximately 365 cubits, the number of days in a year. This perimeter, divided by twice its height, is equal to pi, a famous irrational number in math. The chamber built inside of the pyramid uses measurements of the Pythagorean theorem, 3, 4, and 5. These are just a few of the math facts that are immersed in this ancient wonder. Here, on the northeast side of Australia, we find ourselves at the Great Barrier Reef. This is one of the 7 wonders of the natural world. The amount of marine life living within this beautiful reef is immense. It exceeds 2,000 kilometers in length and is approximately 133,000 square miles. It includes 3,000 separate coral reefs and 900 islands. There are 1,500 species of fish, 350 species of coral, 175 species of birds, and 30 species of whales and dolphins that are living here.
If we could determine the number of creatures that live here, the number would be so large that we would have to use scientific notation. Scientific notation could also be used when talking about the large amount of people who visit this wonder of the world every year. We are 2 out of 1.6 million people who visit the reef each year. In scientific notation, this would be 1.6 times 10 to the 6th power.
Now that we have traveled the world,
We can see that math is everywhere.